Can we generate a low-tech anthropogenic island as a buffer from the nuclear age? My proposition harnesses the mangrove as a piece of biocultural architecture in order to regenerate the nuclear test site of Inawatak Atoll. Between 1946 and 1958, the United States detonated 67 nuclear bombs on, in and above the Marshall Islands, vaporizing whole islands, carving craters into its shallow lagoons, and exiling hundreds of people from their homes. A byproduct of the nuclear age, the Runit Dome holds more than 3.1 million cubic feet or 35 Olympic-sized swimming pools of the US-produced radioactive soil and debris, including lethal amounts of plutonium. Nowhere else has the United States settled another country with so much of its nuclear waste, a product of its Cold War atomic testing program. The sea level around the Runit Dome also rises every year, bringing about an urgency as waves bring in the potential threat of breaking the concrete dome apart. The unique conditions around the Runit Dome are of historical significance in the age of the Anthropocene. The collision of two environmental phenomena of radioactive waste and climate change. Ecosystem ecology is the concept of studying organisms through an isolated system. The new term ecosystem was drawn from the field of physics to describe the relationship between organisms and their habitat, arguing that one might conceptually isolate ecosystems as a model to study the universe as a whole down to the atom. From the Odum brothers' study of the ecosystems of the Marshall Islands came the term radiation ecology. So irradiated was the marine life in Inawatak Atoll that the fishes were producing auto-radiographs, impressing their own images onto photographic plates and film. The radiation seeps from the dome into its surroundings. From the Natural History of Inawatak book, evidence of radiation throughout Inawatak Atoll can also be seen through studies of the local Polynesian rat, house mouse and roof rat populations. Physically observing the Runit Dome also shows evidence that the concrete is failing. Cracked concrete panels due to spalling, vines and bushes growing between concrete panels, further breaking down the concrete dome structure with their roots. A recent field survey shows that mangrove plants have the potential to absorb radiation from the surroundings. The concentration of UV-absorbing compounds varied between species of mangroves, between sites that would be experiencing similar levels of UV radiation, and between sun and shade leaves. Mangroves have been a part of Inawatak's atoll bioculture as an ecotone that has been significantly reduced as a consequence of the nuclear testing program. Due to its proximity to the sea, parts of the Runit Dome currently sit within brackish water. Mangrove plants can be observed creeping into the dome. By the addition of mangrove bioblocks around the dome, we implement techniques and methods observed from low-tech architecture to create a radiation buffer zone around the Runit Dome. Bioblocks are planted in the ground around the Runit Dome. These bioblocks are biodegradable, degenerating over time to release nutrients into the ground. As the bioblock releases nutrients into the brackish environment around the runic dome, the existing mangrove plants form a protective barrier around the dome, absorbing radiation into its leaves and creating a protective buffer around the source of radiation. These mangrove plants absorb radiation released by the dome, and the growth of mangroves also allow for the restoration of a lost portion of the atoll's bioculture. By recultivating the mangrove bioculture of the Inawatak Atoll, we also respond towards the flooding that occur within the atoll. Mangroves ultimately also provide the natural barrier protecting the human settlements within the Inawatak atolls from flash floodings.